this in some other app besides QuickTime, and we'll see how this works. So hopefully you'll get the same quality of record. Okay, so we're going to do compound E, and we're going to figure out what this is. And we're going to figure it out by, first of all, doing the empirical formula. So the empirical formula goes first. Where am I here? Draw, red marker, okay. And so it looks like I do combustion analysis, and I've got 60 grams of carbon, 13.42 grams of hydrogen, and 26.62 grams of oxygen. So the atomic weight of carbon is 12.011. The atomic weight of hydrogen is 1.008. And that of oxygen to that many sig figs is 16. So that means that that's not a delta, that's an AW, right? That means the moles of this is 59.96 divided by 12. That's going to be about 5, or yeah, 5, right? 59.96 divided by 12 is equal to 4.9966. 4.997. 13.42 divided by 1.008 is equal to 13.31. 13.31, and 26.62 divided by 16 is going to equal 1.66. 1.664. So let's divide all of those by the smallest number to get the molar ratio, and this goes to 1. 13.313 divided by 1.664 is 8 even. And 4.997 divided by 1.66 is equal to 3.01. So this is clear, okay? We can see that the empirical formula then, the empirical formula of this is equal to C3H8O, okay? And it looks like there's the molecular ion, I'm told with this one, is 60, all right? So we can go from there. But first of all, again, that's your 1 out of 1 point, right? So let's do the molecular formula now, and we will, so we know that 3, let me change colors here, 3 times 12 plus 8 times 1 plus 1 times 16 is equal to 36 plus 8 plus 16, which is equal to 44 plus 16, which is equal to 60, okay? And if the molecular ion is 60, then we know that the molecular formula is equal to C3H8O, okay? And that's my second point, 1 out of 1. Now, the molecular ion, so it says the molecular ion doesn't show up at 60, so I'm going to say that that right there is 60, but I'm also going to say that there's my evidence, really. There's my evidence that right, is that we're told that the molecular ion is 60, okay? Next thing we could do, I guess we could take away 15 and say that this must be the molecule minus a CH, how do you spell C? Minus a CH3 group, the M plus minus a CH3 group, right? Because CH3 is 15. So we probably have a CH3 on here. All right, we already got our point for the mass spec. Now let's go on to drawing the constitutional isomer. So C3H8, that would be saturated, so that means it's an alcohol. C3H8O, C3H8O. Could be an ether though. Those are the only possibilities for constitutional isomers. So I get a point for that also. Let's go to green here, right? And let's do the IR evidence for this, okay? So there are 2 peaks here. This is clearly an alcohol, right? There's my OH, that's that bond right there. And you're supposed to draw the structure on there for your point. I'm going to go a little further though, and I'm going to say this is clearly an sp3H. I shouldn't say clearly, but I know I have got sp3 carbons in here because I'm saturated. and also because there's a bunch of hydrogens, right? So there has to be one in there, and that's definitely it, okay? Nothing below 1500, okay? So don't put anything down there. It's the fingerprint region. And we got our point for that. So there's a 1 out of 1 point for that. Next thing I need to do, and I'll go back to red, is I need to say, well, let's take a peek down here at these, okay? Let's take a peek at this to see if we can narrow the constitutional isomers, and we'll do a prediction. So it looks like I've got three signals, definitely three signals, all right? And so if I go here, that's different than this methylene, which is different than that methylene, which is different than that hydrogen. That's got 4 signals, okay? This one has got, those two are identical. There's another one, and there's another one. So that's got 3 signals. That was squares, okay? That's got 3 signals, and this one's got also 3 signals, okay? So it could be, this has got 3 signals. So it could be one of these two. However, I know it's an alcohol. I should have crossed it out. When I saw it was an alcohol, it's not that. So it's already definitely that. We know it's isopropyl alcohol. But I'm going to go ahead and make predictions, because this is what you're supposed to do to tighten your story, right? So we're going to say type number, try to write a little slower so my pen doesn't mess up, number of neighbors, n+1, and shift. Okay, I don't have my book open, but remember it's about page 666. It's the page of the beast, right? So here I'll call that A, I'll call this B, and I'll call that C. Marker's going a little slow. A, how many are A? There's 6 are A, right? There's 3 here and 3 on the other side. How many neighbors do they have? They have 1. So they are going to be a doublet. It's going to be a doublet. And it's, I'm going to page 666 and 664 or 2 now to look for that chart. Table, I don't remember what, table 15.1 and 2. All right, going there now. I see 15.2, and then I go a couple pages over to 663. So these are the closest thing to this, and this, you should have this on your paper, right? You're testing to see if you get the same thing I get. The closest thing to this is 0.9, right? Going a little fast. My marker's not working too well. B, okay. How many are B? There's only 1 hydrogen there. It has 3 neighbors on that side and 3 on that side, so it's got 6 neighbors. So it's going to be a septuplet, right? And its shift, that's right on the hydrogen, or right on the carbon with the oxygen. So that is 3.7. That's from the other table. 3.7 is the best guess for that. And C is on the alcohol itself. And that, there's only 1. This does not, because of hydrogen bonding or for whatever reasons, it has no neighbors. I know it's got that hydrogen right there, but go back and look at the video on this one. Hydrogens that are on oxygens technically have no neighbors at all. That's not always the case, but we treat it like it is for our guess, okay? And the table on page 666 says 2 to 5. So these are the numbers that you'll get full credit for, all right? I could be wrong on that. You know, you see me make mistakes from time to time, but I'm pretty sure that's right. And we're going to go, when I'm grading the exam, right, I'll make sure that absolutely certain I'm right. Okay, so I get 1 out of 1 point for that because I wrote my table out, which you're required to do. All right, now let's go back to blue, and let's assign peaks, okay? Do I have a 6 next to a doublet, which is close to that range right there? And I absolutely do. Do you see how writing the table out in advance just totally soothes my soul? Right? So I get that. Do I have a 1? Let me change colors here. Do I have a 1 next to a septuplet, which is in the 3.7 range? Absolutely do. There it is, okay? So this is B, right? Let me go back to red. This is, or rather blue. This is A, okay? And you know where I'm going with this, right? Look it, I have a number 1 next to a singlet in the 2 to 5 range, and there it is. So that is C. And there's my last point. Okay, I'm not going to say anything about the spectral, the carbon 13 NMR spectral data. I think that that's a nice, clean explanation. We'll cut that off there.